In this video, I will discuss the characteristics of gasoline. Gasoline is a mixture of hundreds of different hydrocarbons. Gasoline is also called gas or petrol. The major characteristics of gasoline are the following. 1. Volatility. Volatility is one of the most important characteristics of gasoline. It has been defined as the tendency of gasoline to pass from the liquid into the vapor state at any given temperature. It refers to the base with which the gasoline vaporizes. Gasoline is highly volatile because it vaporizes at a relatively low temperature. At 40 degrees Celsius it vaporizes with a vapor pressure of 5 N per centimeter to 10 N per centimeter. Because gasoline is a mixture of different hydrocarbons, each having a different volatility of boiling point, the proportions of low velocity and high volatility hydrocarbons must be correct for the different operating conditions as follows. Easy starting. For easy starting with a cold engine, the gasoline must be highly volatile, so that it will vaporize readily at a low temperature. Thus, percentage of the gasoline must be highly volatile. This percentage must be higher for colder northern states than that for the south. Quick wearing. For quick warming of the engine, after it has been started from cold, the gasoline must be fairly volatile. The speed with which the engine warms up depends upon the volatility of the gasoline. The volatility for this purpose does not be as easy starting. Good economy. For a good economy or maximum kilometers per liter, gasoline must have low volatility and high heat content. High volatility reduces the economy and since it may produce an over-rich mixture under many operating conditions. The gasoline's low volatility tends to burn more effectively. Smooth acceleration. For smooth acceleration, a sufficient proportion of the gasoline must be sufficiently volatile. During the acceleration, an extra amount of gasoline and also air is delivered to the engine. If this gasoline does not vaporize quickly, the air-fuel mixture will be too lean momentarily, which will cause the engine to hesitate. But immediately after, as the gasoline begins to evaporate, the mixture will become temporarily too rich. Thus, for smooth acceleration, a sufficient proportion of the gasoline must be sufficiently volatile. Freedom from vapor lock. To prevent vapor lock, the gasoline must have low volatile. If it is too volatile, the engine heat will cause it to vaporize in the fuel pump. This can cause a vapor lock which prevents normal fuel delivery to the carburetor. Thus, the percentage of highly volatile gasoline must be kept low to prevent vapor lock. Freedom from crankcase dilution. If the invaporized liquid gasoline enters the engine cylinder, it does not burn, but runs down the cylinder walls and enters the oil pan, where it dilutes the oil. It washes lubricating oil from the cylinder wall, increasing the wear of walls and rings. Hence, to avoid damage from crankcase dilution, the gasoline must be sufficiently volatile, so that only a little may enter the cylinder in liquid form. Volatility blend. It is clear from the above discussion that no volatility would satisfy all engine operating requirements. On the hand, gasoline must be of high volatility for easy starting and good acceleration. On the other hand, it must be of low volatility for a good economy and to oppose vapor lock. Thus the gasoline must be a mixture of various amounts of different hydrocarbons having different volatility. Such a mixture satisfies the different operating requirements. Indication of volatility. The volatility of gasoline is indicated by its distillation characteristics. The distillation is carried out by heating 100CENTICENTISECOND of the gasoline in a flask at a constant rate of temperature rise. The vapor is condensed and collected. The temperature at which each successive 10 cc of gasoline distills over is noted, and the volatility of the gasoline is discussed in terms of these temperatures. 2. Purity. The gasoline to be used as a motor fuel must be free from dirt, grease, and traces of chemicals and water. A reputed refiner is very careful to see that such foreign material is present in his gasoline. The retail marketer is also responsible to some extent for the purity of the gasoline which he delivers to the public. 3. Sulfur content. The crude oil consists of sulfur. While refining the crude oil, part of the sulfur is carried to the gasoline. Too much sulfur is likely to corrode cylinder bores, bearing surfaces, and exhaust systems. Hence, the refiner must have to remove harmful quantities of sulfur. 4. Gum content. A good fuel should have a minimum amount of gum. When the gasoline is exposed to air, some of the hydrocarbons are oxidized into sticky gum. The gum creates a number of operating difficulties such as excessive engine deposits, sticking of valves and piston rings, coated intake manifolds, etc. The gumming tendencies of the gasoline can be controlled by proper chemical treatment or by adding suitable gum inhibitors or antioxidants. 5. Anti-knock quality. The pressure increases evenly inside the engine cylinder during the normal combustion of the air-fuel mixture. But under some conditions, the last part of the compressed air-fuel mixture explodes, which suddenly increases the pressure. This sudden increase in pressure causes a rapping or knocking noise that sounds like a hammer blow on the piston head. Some types of gasoline produce much more knocking than others. Because knocking is an undesirable property of gasoline, refiners try to improve the gasoline by reducing the knocking tendencies. Certain chemicals when mixed in the gasoline reduce the knocking tendency. The actual rating of the anti-knock tendencies of the gasoline is given in terms of octane number. The octane number of the gasoline is determined by matching it against several mixtures of normal heptane and iso-octane in a test engine under specified test conditions, which give the same degree of knocking in the engine as the gasoline being tested. 6. Calorific value. The engine fuel must have a high calorific value. It has been seen that all gasoline has approximately the same calorific value, about 24,000 Chu per kilogram. 7. Operating economy. The nature of the fuel is one of the most important factors which determines kilometers per liter of the fuel. Other factors are engine condition, speed, nature of the road, vehicle weight, and load upon it. A low-grade fuel usually gives fewer kilometers per liter than a high-grade fuel. As a result, the cost per kilometer of operation may be higher even though the fuel costs per liter